Okay, so the first thing we're going to do is create our points in which our vector forces or field forces are going to be created from. So I'm going to select that green curve that's wrapping around the sidewalk there. I'm going to go ahead and reference that into Grasshopper. So in order for these vector forces to work, you actually have to use a open curve. If it's a closed curve, it's going to create a lot of issues when you try and create a surface from that. So you could really kind of make this curve all the way up until like they're barely touching. As long as it's an open curve, it'll work. It's when it's closed that it starts to create issues. So we have our curve here. We also want to divide this into a series of points. So I'm going to go to curve and divide curve, this very top one. And I'm going to divide this curve into, let's say, 120 points. So I'll just type 120 to drag it in there. And now you have a bunch of points along here. This is really going to control the resolution or the detail of your surface. The next thing we need to do is create our bounding box. So this is what's going to contain our vector forces so that they don't actually go beyond our designated site location. So what you can do is then go over to surface. I'm not sure where it's actually. I'll just type bounding box. You'll see bounding box where it's this cube with a couple points connected to it. So I'm going to take my curve and drag that into there. And that's what creates this bounding box for our site. So you can see that it's a nice closed B-rect. This is, like I said, is going to be what's containing our forces. So it's going to allow it to not only go horizontally within our site, but also vertically, so we can actually have our forces start to go on the z-axis. But in order to do that, we need to give it a little bit more space to do that. So we're going to scale our bounding box in the z direction. So I'm going to start typing scale, and I'm going to select the scale and u, so the non-uniform factors. I'll drag my box into there. I can turn this one off now, and I'm just going to scale it on the z axis. So I'm going to do maybe, let's do something like 10. That gives us some nice volume to work with. And again, you can always make it larger or smaller. It's up to you. This is only a reference geometry, so you can turn this off. Let's actually rename this bounding box, just to help us remember. So we have our bounding box. Now we can start creating our vector forces. The first one to work within this is to use the actual vector field, not the spin charges that are going to be used later. So I'm going to go to vector, choose field, and use the vector force component. Let's move this over here. We'll move this right around here. And I'm going to first need a line to create our vector. So I'm going to zoom in. Like I said, there's some really small green curves near the bottom of this model. I'm going to actually select this one on the left is slightly angled up. The one on the right is perfectly flat. let's choose this angled one for now. So this is the one on the left-hand side. So I'll reference this curve into Grasshopper. I'll drag that into there. So you can see there's this arrow starting to be created to show that vector direction. For the vector forces, it really doesn't matter if you change the height of it or if you make it go left or right. It's really just a direction. It has nothing to do with its location. If you start to rotate it, it'll create some change, but it really doesn't matter where its location is. So we have this vector force. Is everybody able to follow along for the most part, or should I?
I'm sorry, I'm missing those couple of lines. I'm searching real hard for.
So bounding box and.
So I'm up the bounding box, right?
Mm-hmm.
And then, so vector force, just the two angled lines, I'm just having difficulty finding.
There, you're gonna have to zoom in, and you'll see them. They're near this tree.
Did you hide something to see them? I see your big red box is gone.
Yep, I turned that off. Like I said, this is going to be recorded, so
yeah, but then I'm stuck right there.
Try and reference that, just so for the sake of getting this finished in time. So we have our vector force, and you'll see the other thing that it's asking for are the bounds. This is what we use this component for. This is why we created that bounding box, because this is what's going to serve as our bounds for these forces. So I'm going to go ahead and drag that into there now. So we have a force, we have some points. Now we can start to bring them together. And because we're going to be adding forces along the lines, we want to use a component where we can easily add inputs. So I'm going to go over to sets. I'm going to go to tree, and I'm going to select this merge component. You can go through that, or you can just type merge on your keyboard. So merge, you'll see it's these different colored lines converging into this thick black arrow. That's what it looks like. So I'm going to drag that into this first input, so D1. I'm also going to go back to vector, field, and do merge fields. So I'll drag that into there as well. So this first one, this first merge is just merging the data all into one output, and then it's taking all those outputs and merging those fields together. So this is like merging the data, this is merging these vector forces, or these vector and, in our case, some spin forces at one point. So we have our field and we have our points. Now we can actually create field lines. So I'm gonna, again, stay within the vector, use field, and do field line. This is asking for the field, so that's what's coming out of this merge component. It's also asking for points. That's what this divided curve is doing. So I'm gonna right click on this to flatten it. And then I'm gonna drag that into our p-value over here. And now you can see that there's these lines that are being created. These lines are in the direction of that line that we have for our vector field. So you can see that if I start to rotate it on this red axis, that it's actually going to start to change the direction of those curves. If you change the size of that, so right now it's pretty short. If you make it longer, oops, I'm not doing anything for this. It doesn't make a whole lot of difference until we start to merge fields together, so it gives it its own strength. So there's our first component. I'm gonna make this so it doesn't angle too high up. Let's drop it down a little. Okay. So it's not doing a lot of interesting things, but what we need this to do is to help kind of counter our other spin forces so they aren't too crazy. This is essentially just going to make sure that there's a force that's going in this long direction. Now we can start to apply some spin forces. So I'm going to stay within here. I'm going to choose field, and I'm going to choose spin force. This is asking for a plane to start. So we could just reference this point, but it's just going to make a flat spin. We want to actually be able to rotate this spin force as well. So I'm going to reference the point. So I'm going to make the point component, right click, say set one point. I'm going to start with this point on this end, so the high end of our site. So it's right there near the pathway. It's fairly low. And so I'm going to use this to create an origin for a plane to rotate. So I'm going to choose vector, plane, and construct plane. Drag that and drag this into the O value. So now you'll see that there's a plane. This is what we're going to actually use to rotate our spin force on. We need to do a little bit more to allow for us to spin that plane or rotate it. So I'm going to double click my canvas and type rotate. I'm going to choose this one where it's showing that kind of curved arrow with the plane underneath for rotate. There's quite a bit of options. So make sure you choose this one where you can see the plane underneath with this curve on top. So I'm going to spin that geometry. I need to know a plane to rotate it on. So I want to spin this so that it starts to kind of go on this direction. So that's going to require a ZX plane. So I'll stay with here. I'll choose plane and use the XZ plane. I'm going to also drag this into the origin there. So you can see now these are intersecting with one another. I'll drag this into the plane input here. I'm going to change this angle from being in radians to degrees. So I'll right click it, choose degrees. And that way I can use a slider to rotate that. So I'm going to do something like -100, less than 0, less than 100. Drag that into there. I'll turn off all of this. So I just have my rotated plane. And now you can see this is rotating our plane. This is what I'm going to drag now into the plane of this force spin or spin force. So you can see now you have your rotating or your spinning force, and it's going to follow whatever the angle of that plane is. Some other things that you can adjust with this is the strength of that spin, the radius of the spin, the decay of it, as well as, again, the bound. So let's first plug this bounding box into here as well. This, again, is going to be used to contain all our forces. I'm going to make it a little bit more angled. I'm going to choose my strength, so maybe that's around like 75. Radius, I can make that pretty large too. So maybe 75 and 50, and let's just see what that does. So you can start to see it's fairly large in our workspace. I'm going to now take that F spin and drag it into this merge component where it has the D2. And now you can start to see it having this immediate impact on those other forces at play. Starting to do something pretty cool. So you can start to see it takes those vector lines that are being projected up from this one. It's then starting to get warped and distorted to lift it up and then start to carry it down some. You can start to play around with the strength and the radius to see what that does to it. So if it's weaker than the other one takes over. If you start to make that pretty powerful, it starts to overpower the other forces. Is everyone getting a similar outcome that's following along? Yeah, Alan.
What is that deal?
Which one?
Deal next to
This is your plane, so construct a plane. And then you're rotating it on your XZ plane.
the rotate geometry goes out into,
So just rotate.
I'm sorry, it rotates geometry goes into F.
Yep.
E. Yeah. There you go.
And so what I'm going to do is this part that I just made the spin force, I'm just going to copy it and paste it underneath and apply this other point for my field or my spin field. So here's my copied part. I'm just going to reference now this point. And I'm going to rotate this as well to go in a different direction. Maybe choose slightly different strength and radius. Again, it's probably best to just plug, again, do the same thing. We're going to take this and plug it into this merge component. So now you can see, now that's starting to affect this other side of our force field. I'm going to reduce the strength. Oops. Or maybe the radius some. Oh, I'm choosing the wrong one. Oops. So yeah, start playing around with the rotation of these spins, the strength, the radius. You can move these around. So if I take one of those points and start moving it on around the site, you can start to see what that makes.
You know, I'm not affecting those, the contour lines. Can I see where you're coming into?
So these should be merged and then merging a force.
Yeah, sorry. So, merge, right?
Mm-hmm.
And then force.
Yep.
Yeah, and then force comes out.
Yep.
Into the divide curve, right? Going into that last piece of the for our last 2 points.
Yeah.
What goes into the bounds of the spin?
So this is what I said. The bounding box, is what's.
I'm in the right one. I might have selected the wrong one. No, I'm in the right one. I'm not affecting those lines.
Well, we'll take a look at it later. Okay, so hopefully something might be produced for some of you. So you'll see that there's still this kind of weird gap between these segments, and we need to make sure that these lines extend all the way to this side as well. And that has to deal with our F line, so this field line component. If you look at this input here, it's looking for a number of samples. It defaults to 1,000. That's quite a bit of samples, but we need to increase that just so that it fully extends over there. So I'm going to create 5,000 unit slider, see if that helps. So you can see it's starting to move some of those. So I'm going to keep dragging this until I get, so it looks like that's the minimum. So we might have some weird things that are preventing this curve from getting all the way over there. So I'm going to take this vector curve, I'm going to shrink it a little maybe. Oh, maybe we want to make that stronger.
My vector curve is not long enough. How are you extending that?
So I'm just using the gumball to drag that.
Oh, now those lines are extended out. I should be
Mhm.
in the middle. This is all wrong.
Is it okay if they overlap?
Yeah, there might be some overlap for sure. There could be some interesting undercutting happening. I'm going to open up my previous one just to. Ooh. Is everyone getting some kind of creation at this point? Did you reference that one? Yeah. Okay. I mean, it takes a little bit of finesse. You might have to move it around. That sometimes helps. You might have to reduce your vector curve here or increase it. Hmm? That goes to this F line over here. So this is the output where you want to increase that step size or number of samples. I'm going to reopen this file real quick.
Yeah, I'm not sure why I'm not. My vector forces are not affecting the lines.
Okay. Okay. So does everyone have these field lines that are being created though? Okay. So like I said, I can provide this one because right now it is luckily showing them extending all the way. it probably has a lot to do with this curve over here. It's very finicky, so if I were to change the size of that, actually that's fine. Might have to do with some of these spin forces though. So you can try and match these ones. I'll upload this just so you have something working to start with, and then it's really about changing these slider values that are rotating your spin forces as well as the strength of that. So I will upload that because I want you guys to have at least something that's functioning. So once you get to this point where you have these complete line segments, something that's kind of cool, what you could see what this bounding box is actually doing. If I were to disable it, you can see this is really what those different vector forces are doing and starting to create something really crazy and wacky. But by having that bounding surface, it's containing it within our site. Okay, so this next part's pretty simple in terms of creating our surface, but what do you notice is happening with this surface or these lines, especially when you're looking at it from right to left? Yeah, these are digging into the ground, which is fine, I think, but what's happening at the end of these forces? They're way higher, right? That doesn't exactly seem like a practical solution for this landform. So we need to do a little bit of work to actually create a very similar condition to match this start point and this end point. I'm actually going to save this part of the script and have you guys follow along from here. So for anyone that's struggling, so maybe I will be much more generous in this case in providing. So this is field forces. And let's go ahead and so if you've moved either those points or this line around, you might want to just reopen this file so that it works correctly, and then you can manipulate it from there. But once you have that, so like I said, we want to make it so that the end of these lines start to go flush with the bottom of this site. So instead of having them going in all sorts of weird directions or heights, we want them to all kind of meet the existing grade. So in order to do that, we're going to take these field lines and deconstruct them into some points. So I'm going to go to curve, divide the curve, and I'm going to keep it probably at its default value of 10 segments. So you can start to see all those curves being divided into a series of points. What highlight? This? You just select all of them and then you hit Control G to group them. So now we're going to, like I said, blend this end of our landform into our existing grade. What's also nice about this is that this is just already kind of set flush with our C-plane. So I'm going to use the project to C-plane component. So project, and you can see this component that says project an object onto a plane. So I'm going to connect these. And now you can see that these points have been projected pretty much onto a flat surface. So what we're going to do now is essentially determine, you know what, like these ones we want to bring down versus as we get further away from this side of our site, we want it to return to those existing points. So let's go ahead. I'm going to turn these off and give them a quick color affiliation. So here's our pink points, which are our initial points. Here's the ones we've projected. So I'm going to find the vector direction from these ones to these ones that are projected down. So I'm going to go to vector, vector, and choose this one from vector 2 points. I'm going to use this first component where I divided them as my A input, and then the ones I projected down as my B input. So this is basically just telling us what that movement is from, for example, this point to that one that's been projected down. And what we're basically going to do is say, okay, for these ones that are really close, return it to this projected, but then as it gets further away, taper back to the original. So in order to do that, we need to use a graph mapper to create that kind of fluid transition. So I'm going to just go ahead and create a number slider for this. I'm not going to change the value, but I am going to use this as a reference for one of these other components I'm going to use. From this, I'm going to create a series of numbers. So I'm going to go to sets, series, start at 0, step size 1's okay. But then, yeah, I want to have this 10 count. So I have 0 to 9. And I'm actually going to need one extra point. So when I drag this into a count, I'm going to change the expression. So I'm going to right click this C for the count, change it to expression and type x plus 1. Just so we know we have the same number of output where you can see there's 11 here and 11 here. Now I'm going to use my graph mapper to change these. So I'm going to drag this into my graph mapper. I'll right click to change the graph type, and I'm just going to use the Bezier graph type. I'm going to right click this. I'm going to change x 0 is going to stay at 0, but x1 is going to change to 10. Hit OK, and then that's really all you have to do in the edit for this. So I'll hit OK. So that means every step size is going to correspond with that vector point.
Can you repeat that last step? I'm sorry. You right mouse clicked it and
So I double clicked it
double clicked.
and changed only this x1 to 10. So now I'm going to use this, and again, like I'm not going to go too much into this because it's a little bit difficult to explaining how these data sets work, but essentially this last one is index item 10. The very first one is index item 0, and we're going to say start at 10 and start to slowly change that multiplier. So we're going to multiply this vector by our graph here. So I'm going to use math multiplication, drag that into there. I'm just going to graph this just to make sure. So now I have my new vector value. I'll actually drag this down so it starts to create this kind of curve, so I can smoothen that out as well. And now I'm going to move these original points, so these ones that I initially divided everything by. And I'm going to use this multiplier as this value. Oops, let's not graph that. So I'm actually not going to graph it. I'm just going to keep it flat. So here's these ones. So let's go ahead and turn off these parts. I'll even turn off our flow line here. And I'm going to turn this off and also give it a custom color so you can just see the difference clearly. So the pink is what that original one created. And now these black ones are what's kind of making it flush with our existing grade. So you can start to see how they kind of start to fade into that existing contour. Does everyone kind of see that? That's what this graph mapper is doing. If you see how I change this, this is what's altering that contour so that it starts to kind of return to grade. But you can see it eventually kind of tapers back to those original points where there's not much difference between the two. But overall, you can see that the pink is where it's really kind of crazy at the end. And now the black, you can see how those start to return to the grade. So the last step, again, this is just as a kind of a reference, we need to make this into a surface. So here's our new points. So you can start to, see how that goes back to the grade. And then the last thing we're going to do is actually create a surface from this. So I'm going to go to my surface component or tab, choose freeform, and do surface from points. I'm going to drag this G output or these points into here. I'll flatten it. And now I just need to make sure that my U count is the same as the original one. And in order to find your U count, this is really the number of field lines you have. So I'm going to go to sets, list length, drag this into there. And I'm going to use the list length component and drag this into my U count. And now you have a nice solid surface.
Repeat that list length again. You grabbed it.
So I use that out of my F line or the field line component. That gives me a length or a number. So 126. I drag that into the U count of the surface from points component. And I'll even bake this to show you what it looks like. So a pretty cool looking surface. So you can see what that looks like versus what those initial lines look like. So I think I'll just stop it here. We'll cover the path and those other things on Thursday.